Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 11 of 24. A rogue script written by a junior developer can easily rack up a $10,000 OpenAI bill overnight. The underlying provider platform keeps accepting requests as fast as the loop can fire them. Virtual keys for FinOps are how you stop this before it happens. There is a common confusion between master keys and virtual keys. You must never give your master key to a developer. The master key is your administrative credential. Its primary purpose is to authenticate your platform to create virtual keys. Virtual keys are the restricted credentials you actually hand out to developers or applications to use in their code. You create a new credential by making an HTTP post request to the key generate endpoint on your LiteLLM proxy. You authorize this request using your master key as the bearer token. The body of this request is where you define the financial guardrails. Consider a scenario where you are provisioning access for a summer intern. You want to ensure they have enough access to build a prototype, but you need an absolute guarantee they cannot burn through your infrastructure budget. You pass two specific parameters in your JSON payload to enforce this. First, you define the financial cap by setting the max budget parameter. If you set this value to 10, you allocate exactly $10 to this specific key. This is a hard lifetime limit. Once the total cost of all prompts and completions tied to this key reaches $10, the key is automatically disabled and will reject all further requests. Second, you control the velocity of those requests by setting the RPM limit parameter. RPM stands for requests per minute. If you set the RPM limit to 1, the proxy strictly enforces a 1 request per 60-second window. If an accidental infinite loop in the intern's code tries to fire 100 requests instantly, the proxy processes the first one and immediately rejects the remaining 99 with a standard rate limit error. When you send this payload to the generate endpoint, LiteLLM processes the rules and returns a response containing the newly generated virtual key. This key looks identical to a standard provider credential, typically starting with an SK prefix. You give this string to the intern. Here's the key insight. The developer uses this virtual key exactly as they would an OpenAI or Anthropic key, pointing their standard client library at your LiteLLM proxy URL instead of the public internet. When a request arrives, the proxy intercepts it. It queries its internal database to verify the virtual key exists. It then checks if the key has exceeded its $10 budget or its 1 request per minute velocity limit. If the request clears both checks, the proxy swaps the virtual key for your actual corporate API key and forwards the payload to the provider. When the provider responds, the proxy calculates the exact cost of the prompt and completion tokens based on that specific model's published pricing. It deducts that fraction of a cent from the virtual key's $10 budget, records the transaction, and sends the response back to the developer. The developer is completely unaware of the underlying credential swap or the internal accounting. By enforcing limits at the proxy layer, virtual keys intercept unauthorized or runaway requests before they ever reach the billing provider, mathematically guaranteeing that a compromised or poorly written script can never exceed its assigned budget. Thanks for listening. Happy coding, everyone.